geothermal energy in the United States generated a record of about 16.792 million megawatt-hours in 2012, narrowly beating the previous record of 16.789 set in 1993. In 2012, the United States led the world in geothermal electricity production with 3,386 megawatts of installed capacity. The largest group of geothermal power plants in the world is located at the Geysers, a geothermal field in California. The United States generates an average of 15 billion kilowatt-hours of geothermal power per year, comparable to burning some 25 million barrels of oil or 6 million short tons of coal per year. In the 12 months through April 2013, geothermal energy generated 16.9 million megawatt-hours, 0.41% of total U.S. electricity. Geothermal power plants are largely concentrated in the western states. They are the fourth largest source of renewable electricity, after hydroelectricity, biomass, and wind power. A geothermal resource assessment shows that 9 western states together have the potential to provide over 20% of national electricity needs. History. According to archaeological evidence, geothermal resources have been in use on the current territory of the United States for more than 10,000 years. The Paleo-Indians first used geothermal hot springs for warmth, cleansing, and minerals. The first commercial geothermal power plant producing power to the U.S. utility grid opened at the Geysers in California in 1960, producing 11 megawatts of net power. The Geysers system continues to operate successfully today, and the complex has grown into the largest geothermal development in the world, with an output of 750 megawatts. Plants. The largest dry steam field in the world is the Geysers, 116 kilometers north of San Francisco. It was here that Pacific Gas and Electric began operation of the first successful geothermal electric power plant in the United States in 1960. The original turbine lasted for more than 30 years and produced 11 megawatts net power. The Geysers has 17 megawatt of active installed capacity with an average capacity factor of 63%. Calpine Corporation owns 15 of the 18 active plants in the Geysers and is currently the United States' largest producer of geothermal energy. 2 other plants are owned jointly by the Northern California Power Agency and the City of Santa Clara's municipal electric utility. The remaining Bottle Rock power plant, owned by the U.S. Renewables Group, has only recently been reopened. A 19th plant is now under development by Ram Power, formerly Western Geopower. Since the activities of one geothermal plant affects those nearby, the consolidation plant ownership at the Geysers has been beneficial because the plants operate cooperatively instead of in their own short-term interest. The Geysers is now recharged by injecting treated sewage effluent from the city of Santa Rosa and the Lake County Sewage Treatment Plant. This sewage effluent used to be dumped into rivers and streams and is now piped to the geothermal field, where it replenishes the steam produced for power generation. Another major geothermal area is located in south-central California, on the southeast side of the Salton Sea, near the cities of Niland and Calipatria, California. In 2001, there were 15 geothermal plants producing electricity in the area. Cal Energy owns about half of them and the rest are owned by various companies. Combined, the plants have a capacity of about 570 megawatts. Hudson Ranch I Geothermal Plant, a 50 megawatts plant, opened in May 2012, the first in the area in 20 years. A second similar plant is to open in 2013. The Basin and Range Geologic Province in Nevada, southeastern Oregon, southwestern Idaho, Arizona and western Utah is now an area of rapid geothermal development. Several small power plants were built during the late 1980s during times of high power prices. Rising energy costs have spurred new development. Plants in Nevada at Steamboat Springs, Brady, Desert Peak, Dixie Valley, Soda Lake, Stillwater and Bear War now produce about 235 megawatts by state installed geothermal capacity in megawatts by state as of February 2013. Production and development, with 3,040.27 megawatts of installed geothermal capacity, the United States remains the world leader with 30% of the online capacity total. The future outlook for expanded production from conventional and enhanced geothermal systems is positive as new technologies promise increased growth in locations previously not considered. As of August 2008, 103 new projects are underway in 13 new states. When developed, these projects could potentially supply up to 3,979 megawatts of power, meeting the needs of about 4 million homes. At this rate of development, geothermal production in the United States could exceed 15,000 megawatts by 2025. The most significant catalyst behind new industry activity is the Energy Policy Act of 2005. This act made new geothermal plants eligible for the full federal production tax credit, previously available only to wind power projects and certain kinds of biomass. It also authorized and directed increased funding for research by the Department of Energy, and enabled the Bureau of Land Management to address its backlog of geothermal leases and permits. In April 2008, exploratory drilling began at Newberry Volcano in Oregon. In 2009, investment bank Credit Suisse calculated that geothermal power costs 3.6 cents per kilowatt-hour, versus 5.5 cents per kilowatt-hour for coal, if geothermal receives loans with lower rates than offered by the market. Reliability. Unlike some other renewable power sources such as wind and solar, geothermal energy is dispatchable, meaning that it is both available whenever needed and can quickly adjust output to match demand. According to the U.S. Energy Information Administration, of all types of new electrical generation plants, geothermal generators have the highest capacity factor, a measure of how much power a facility actually generates as a percent of its maximum capacity. The EIA rates new geothermal plants as having a 92% capacity factor, higher than those of nuclear, gas, or coal, and much higher than those of intermittent sources such as offshore wind or solar photovoltaic. While the carrier medium for geothermal electricity must be properly managed, the source of geothermal energy, the Earth's heat, will be available, for most intents and purposes, indefinitely. In 2008, the U.S. DOE funded research in enhanced geothermal systems to learn more about the fracture systems in geothermal reservoirs and better predict the results of reservoir stimulation. The DOE Geothermal Technologies Program provided funding to establish the National Geothermal Data System through the NGDS. Many older paper archives and drill logs that have stored at state geological surveys are now being digitized and made available for free to the public. Environmental effects. The underground hot water and steam used to generate geothermal power may contain chemicals that could pollute the air and water if released at the surface. Hydrogen sulfide, which is toxic in high concentrations, is sometimes found in geothermal systems. Newer methods of generating geothermal power separate the hot steam collected underground from the steam used to power turbines, and substantially reduce the risk of releasing air-polluting contaminants. The water mixed with the steam contains dissolved salts that can damage pipes and harm aquatic ecosystems. Some subsurface water associated with geothermal sources contain high concentrations of toxic elements such as boron, lead, and arsenic. Injection of water in enhanced geothermal systems may cause induced seismicity. Earthquakes at the Geysers geothermal field in California, the largest being Richter magnitude 4.6, have been linked to injected water. Possible effects include scenery spoliation, drying out of hot springs, soil erosion, noise pollution, and chemical pollution of the atmosphere and of surface and groundwaters.